Solving systems with three variables. So the steps to solving systems for three variables is the following. First thing you're going to do is you're going to eliminate a variable from equations 1 and 2. It does not matter which variable, it could be x, y, or z. Step 2 is to eliminate that same variable from equations 2 and 3. So what you've just created are two new equations that have only the same two variables remaining, and you are going to solve for those two variables. Then the fourth thing is to plug in those answers to find the remaining variable. So here is our system of equations. 5x minus 4y plus 2z equals 21, negative x minus 5y plus 6z equals negative 24, and negative x minus 4y plus 5z equals negative 21. Word of wisdom. Make sure that you first have written your equations correct. The first time I tried to do this video, I wrote it wrong. That was not very helpful. Next word of wisdom is to make sure you are multiplying correctly, especially with negatives. The second time I tried to make this video, I lost a negative. Don't do that. Do not pull a Mrs. Lascelles. Write your equations correctly and pay attention to your positives and negatives. Okay, so let's try this. Third time. Yes, that is that special. I am not apparently doing a good enough job of paying attention. Step 1 says take equations 1 and 2. So I'm going to call this equations 1, 2, and 3. So I'm going to take equation 1, and I'm going to take equation 2, and I'm going to eliminate one of our variables. It does not matter which variable it is. It can be whatever variable you choose. So I'm going to multiply this bottom equation by a 5. If I do that, I'm going to leave the top equation alone, and I'm going to multiply the bottom equation by 5. So that gets me a negative 5x, a negative 25y, a 30z, and 24 times 5 is negative 120. If I add those two together, my x's are gone, as it was supposed to be. I have a negative 29y, I have a plus 32z, and 21 minus 121 is negative 99. So I've just created my first equation. That is step 1. Step 2 says to take equations 2 and 3 and eliminate the exact same variable. So I'm just going to write down my two equations, making sure, oh, I almost did it again, that I do not write the wrong numbers and that I don't lose one of my negatives. Now, with this equation, I need to eliminate the same exact variable. I eliminated the x on the first one. I must eliminate the x on the second one. So I'm going to multiply this second equation by a negative 1 to eliminate my variables. So I'm going to leave the top equation alone. That one is not going to change. My bottom equation, all negatives become positives, and all positives become negatives. So it equals 21. If I combine those two, the x's are gone, as I wanted it to be. I have a negative y, I have a positive 1z, and I have negative 3. So here are my two equations that I just created. So for step 3, what I'm going to do is I'm going to take those two lovely equations that I just created that only have two variables in it, and I'm going to solve it. This is something that we've done before, equals, if I almost forgot my equal sign. And negative y plus z equals negative 3. Okay, I'm going to eliminate one of my variables. Does not matter which one, I only got two of them. I multiply the bottom equation by negative 29. So I'm going to leave the very top equation alone, and the bottom equation is going to get multiplied by negative 29. So that becomes a positive 29y minus 29z equals, and 29 times 3 is 87, and a positive times a negative, negative times a negative is a positive. Try not to make any of my same mistakes. So y's are gone. 32 minus 29 is a 3z, and negative 99 plus 87 is a negative 12. So if I finish this problem, divide both sides by 3, I get z equals negative 4. Awesome. Now I have the ability within step 3 to find my other equation. So I'm going to plug negative 4 into this bottom equation here. Negative y plus negative 4 equals negative 3. I'm going to add 4 to both sides. Negative y equals 1, which means y equals negative 1. So there's my second equation. There's my second answer. Now, so on step 3, I use the two equations I just created from step 1 and 2 to find my two answers. To find the very last answer, all I have to do is plug those two answers into any of the original equations and solve for the last variable. So let's just say I wanted to use our top equation of 5x minus 4y plus 2z equals 21. Does not matter which one. So I don't have x because that was the variable I eliminated at the very beginning. Negative 4 times negative 1 is a positive 4. 2 times negative 4 is negative 8 and equals 21. So 5x minus 4 if I combine like terms. So if I add 4 to both sides, I get 5x equals 25. So then x equals 5. So for my final answer, it's always alphabetical order, which means my final answer is 5, negative 1, negative 4. So I have just solved a system of 3 variables by doing a lot of elimination.